Lesson 5.3, Sum and Difference Identities. A few more identities that you should have on your sheet. If you're writing your own in your notes, make sure to write these ones down. These ones are important so we can find exact values for angles that won't be on your unit circle. For instance, we could find the sine of 15 degrees, the cosine of 75 degrees using these identities. So these are the three for cosine, sine, and tangent. These will all be on your sheet. The one that you might want to write down that won't be on your sheet is the one I wrote on the bottom, okay, which is simply taking the fact that we know tangent is equal to sine over cosine. Okay, so we can use the sine and cosine sum and difference identities to find the tangent. Example 1, we want to find the exact value of the cosine of 15 degrees. So we got to think about our unit circle and what values we do know for cosine and sine. For instance, on our unit circle we have 30, 45, 60, 90, and so on. We know all of those values. So if we're trying to find 15 degrees, we got to think of two of those values that we can either add or subtract to get to 15 degrees. So this is the same as the cosine of 45 degrees minus 30 degrees. Okay, so we know what the cosine of 45 is, we know what the cosine of 30 is, so we're going to use those known values and the sum or difference identity to find this exact value. So we're subtracting, so this is the difference of cosine, which means we have the cosine of 45 degrees times the cosine of 30 degrees. Since we're subtracting, it's going to be the opposite, so we have plus the sine of 45 degrees times the sine of 30 degrees. Now if you use your unit circle, we know the cosine of 45 degrees is radical 2 over 2. The cosine of 30 degrees is radical 3 over 2. Plus the sine of 45 degrees is radical 2 over 2. And the sine of 30 degrees is 1/2. Okay, so if we multiply these values out, radical 2 times radical 3 is radical 6, over 2 times 2 is 4, plus radical 2 times 1 is radical 2, over 2 times 2 is 4. So if we just write this as one fraction, we get radical 6 plus radical 2 all over 4. So that gives us the exact value for the cosine of 15 degrees using that sum and difference identity. Example 2, we want to prove the cosine of pi over 2 minus x is equal to sine x. So again, we're going to use that same identity we did in the last problem. So this simplifies down to the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times sine of x. Okay, so again we're going to use our unit circle and simplify some of these. The cosine of pi over 2 is 0 times the cosine of x plus the sine of pi over 2 is 1 times sine x. Okay, well we know 0 times anything is just 0 and 1 times anything is just itself, so this simplifies down to sine of x. Example 3, we want to write as the sine of an angle. So in this problem we just need to recognize which identity we need to use. So if we have a combination of sine and cosine being multiplied together, we know it's going to be either the sine sum or the sine difference formula. Since it's an addition sign, it's going to be our sine addition. So we can take this and rewrite it as the sine of 22 plus 13, which is simply going to be the sine of 35 degrees. Okay, so in this example, all we're trying to do is recognize which formula we have to use, rewrite it, and simplify. Example 4, we want to prove the tangent of theta minus 3 pi over 2 is equal to the opposite of cotangent theta. So the tangent formula I like to use is the one that involves sine and cosine. If you want to use one of the other identities, you can, but I just think it's easiest to use sine and cosine since we've already practiced with those. So we can rewrite this as the sine of theta minus 3 pi over 2 over the cosine of theta minus 3 pi over 2. Okay. So if we rewrite this using our sine and cosine difference and sum identities, this becomes the sine of theta times the cosine of 3 pi over 2 minus the cosine of theta times the sine of 3 pi over 2. All divided by cosine of theta times the cosine of 3 pi over 2 plus the sine of theta times the sine of 3 pi over 2. Okay, now we need to simplify some of these. This is equal to the sine of theta times 0, the cosine of 3 pi over 2 is 0, minus the cosine of theta times negative 1. Sine of 3 pi over 2 is negative 1, divided by cosine of theta times 0, plus the sine of theta times negative 1. So again, if we simplify, these first two terms are just going to be 0. So we have, in the numerator, negative times negative becomes a positive cosine theta over a negative sine theta. Cosine over sine, one of our quotient identities, is cotangent, and it's the opposite. So we have gone through that proof using sum and difference of sine and cosine to get to our tangent, simplifying to get negative cotangent theta.